Thank you, Brittany. I want to thank EEA for providing this opportunity for me to present the topic of top 10 security considerations for blockchains and smart contract. I'm VP of Engineering for Wanchain. I'm also co-chairing Crosschain Interoperability Workgroup in EEA. And also I'm teaching a smart contract development course in the University of Texas. And today we have several topics, 6 topics. First one is that we're going to mention the top 10 security hacks, and then we're going to look at the complexity of blockchain security, and then we're going to look at the functional security holes and also attackable ones. And then we are going to talk about 13 or 14 best practice for blockchain security. And then we're going to go beyond a single chain security to cross-chain security. And after that, we're going to have questions. First of all, the hacks. It's hacks in cryptocurrency is something very common in our world today. And I classify these into 3 categories. The first category is the hacks of centralized exchanges. And during the past years, we have about 1.6 billion hacks of cross-chain, not the cross-chain, the single centralized exchanges. And if you look at the way that these exchanges are hacked, they still belong to the cyber security category. They come into the breach of the security system, and they steal the private key, and they hack the hard wallet and transfer funds to an unknown address or to an anonymous address. So these are still the traditional way of hacks. And going to the DeFi ones, it is a bit different because DeFi ones are governed by smart contract, and the way they hack it, or even for some functional security issues, they don't even need a hacker. Sometimes our smart contract actually have vulnerabilities. Most famous one is security bug with Compound, with $150 million assets stolen, or kind of mistakenly sent to wrong people. And if you look at the headline here, is that 80 million was sent to wrong people, and then another 68 million was sent after the fix was found, but pending for the approval of the community. And these are very typical for decentralized applications because there's no centralized government body to take care of all these security things. The community has to decide. And the root cause of this one is very typical of smart contract bugs. Basically, there are 2 bugs for this one. If I simplify it, basically, if you look at the Compound application platform, that is a lending platform. So the earning made by the supplier of the asset is calculated by multiply the supply token with a ratio. And that ratio has to be kind of limited. But because of the bug, that delta index, the ratio is equal to 1 times 10 to the power of 36. And that is a huge number. We know that billion is 10 to the power of 9, and trillion is 10 to the power of 12. Of course, Google is 10 to the power of 100. So this 1 times 10 to the power of 36 is then less than Google, but it's much larger than trillion or billion. And then this caused the fund, the large sum of earnings sent to the users. And to fix this one is very easy. Actually, you actually go to the controller solidity code and find this lines of code and add the equal sign to the lines of code. So one letter change fixed a bug that caused damage of $150 million to the platform. So this is very typical of decentralized application vulnerabilities, and we need to be very aware of this. And there are many DeFi system application being hacked due to the smart contract, and we're going to mention these later on. And another new thing is the hack on the bridges. EEA has a Crosschain Interoperability Workgroup, and we have been looking at security very early stage, and we actually publish Crosschain security guideline as well. This is the one that you can look at it later on. There's a link over here as well. So we have seen at least 1.8 billion dollar loss of asset due to breach hacks, and the latest one is just this month. Nomad, the confirmed ad that one was not initialized correctly, so the verification was done improperly. And also Horizon, the private key stolen, and also attack on this validated nodes of running network. So it's more complex when you compare this with the DeFi hack or the centralized exchange hack. And I'm going to talk about this later on this session for Crosschain bridge security. Yeah, and this is the article that I mentioned. This is published by EA. And the next one I want to talk about is the complexity of blockchain security compared with the traditional security systems or IT systems. So there are 5 things that I classified. First one is the decentralized nature of blockchain. And then second one is the constraint of patches and upgradability. And third one is the trustless and the permissionless environment. And then the fourth one is the private and anonymous nature of blockchain. And then the last one is the high value of impact on businesses. A little bit more details, decentralized nature of a blockchain. In blockchain, there's only one chain, but there are thousands of machines running to send blocks to construct these chains. So any code written deployed to blockchain are going to run in thousands of machines. And these thousands of machines are controlled by different people. And anybody can access and run the blockchain code. This is different from legacy system where the IT company run the code in their secure IT systems. So this is a decentralized nature of blockchain. And second one is the constraint of patches and upgradability. Because blockchains are immutable, and nobody can change it. Once you deploy a smart contract to a blockchain, it stays there. So if you find a security flaw, it's very difficult to patch it or upgrade it. So this causes problems. It's just like a compound case. You find the fix of the smart contract, but it takes a long time, almost a week, to actually patch it through the permission of the community. And then the trustless and permissionless environment. For public blockchain, anybody can join as client node or mining node to the blockchain, and it's open to the global participants. So it's very difficult to build a security perimeter to block bad players from participating. And then the privacy or private and anonymous nature of blockchain. And this one is a case where even users have address, have private keys, have account to run the node, to run the application. They are not affiliated with the social identity. So in that case, the users remain anonymous. And when the hackers get the asset, they can transfer the fund through some anonymous feature, through something that make themselves still unidentified. And then there's another one. That's the fifth one is the high value impact on business. So it's interesting. Sometimes 200 lines of code, 300 lines of code can be a bank itself already. So each line of smart contract code can have a large value affiliated with it. It's just like the one we mentioned. That one line of code defect actually caused the loss of $150 million of assets. Yeah, and we have seen cases where just a simple error in a smart contract caused a project to fail. So these are the complexity of blockchain with security. Yeah, and then if you look at it, it can be the hacking technology can be classified into 3 categories. One is the cybersecurity. This is a very traditional. They have phishing, malware, ransomware, spoofing, geo-data threat, and toolkit, red access, remote access terminal. And then for smart contract, the hack could be on the functional vulnerabilities, data type and data vulnerabilities. Compiler sometimes has problems. And then the randomness vulnerability and also signature. And then for Web3 are off-chain. It's not like smart contract, which is on-chain. Web3 is off-chain, and therefore sometimes hacker can build a verification and proof through some hacking technology to bypass the verification method on-chain, and then they can construct whatever transaction they have, and then also they can hack the web service to construct some user interactions that are damaging to the application, and also they can do the signing itself. So these are the hacking technology that are quite common for crypto space. And then I'm going to go to the smart contract ones. For smart contract, I classify them as two kinds of security holes. One is functional and one is attackable ones. And for functional ones, these are the vulnerabilities that do not even need a hacker to exploit to cause damages. It's just functional bug, and sometimes even the normal use operation can cause damage. Yeah, and this is one case. This is a true smart contract. It's called parity bug, and in this smart contract, if you look at it, it has balance of 306 Ether in it, and with a value of 570 million. And these funds are locked in this smart contract. Nobody can get it out. And the reason for this thing to happen was due to a kill function mistakenly called by a newbie user. So this is the message. I will let you read it. Basically, somebody just sent a transaction to call kill function, and then it just destroyed the smart contract. And then the person replied that you cannot make an omelet without breaking some eggs. So this happened a couple of years ago, and the smart contract is still there, and the fund is still locked. And this is because the kill function, these are very, very sensitive functions, are not guarded properly. Yeah, so the functional hacks, right? There's a fund deadlock. I classify them into several categories. One is the fund deadlock, where there's not a function that can release the fund. So the fund get deadlocked in that smart contract. So you can also call this a black hole case where you just cannot get things out. And then fund leakage is a case where normal user can send a transaction to a smart contract to call a function, and then that function release a fund to them. Right? And this is normally a case where there's a function visibility. Some functions are supposed to be private, but the coder, the developer, mistakenly make it public, and some of them things are not payable, but they make it payable. And also, there's no lack of check on the ownership on the person who called that smart contract. There should be some only owner or required check on the smart contract function, but sometimes developers just forget or did not do that kind of check. And then disable smart contract. This is a case where a function is called to be killed, and this is the case with the mention I just mentioned, and also the self-destruct. These are the functions that are function calls that are allowed in smart contract, in different versions of smart contract. Sometimes these cause damages as well. And then often the smart contract, sometimes project team deploy a smart contract to blockchain, and then they renounce the ownership of the smart contract, and then these smart contracts become orphan. Nobody can manage it, nobody can update it, nobody can release the fund from that smart contract. Yeah, and this is a case where the visibility of function that actually cause a security issue. These two functions, the second function, the send winning function, are supposed to be private, but they mistakenly make it public. In that case, user can call this function directly, and that the smart contract transfer a balance to the user account without any check of the user's identity. So to fix this one, just need to change this public function into private function, and that this withdraw winnings to be the public function, so that people can call this function. When people call this function, there is a check on the users. Yeah, and then this is another case where the sensitive functions such as self-destruction need to be checked very, very carefully. Yeah, and the one I just mentioned were functional ones. You don't need a hacker to hack it, just functional security holes. And the attackable ones are a bit more complex, right? And then this define a security attack by users with malicious intent. So these are less obvious than the functional security holes. And then there are many ways to do it. They can do the underflow, overflow of the variables. They can fake the signature, and they can also do a lot of like a whitelisting things, change the whitelisting of the address that they are supposed to manage the smart contract. Yeah, and this I mentioned that changing the calling faulty internal functions with malicious transactions, changing outside parameters and the conditions for function call, and also changing whitelist addresses and names, and attacking oracles. Oracle is a platform that link traditional legacy system, IT system with blockchain, and that oracle is governed by some trusted entity. But if this oracle get hacked, then they can pass the wrong price information, wrong information to a blockchain, and they will cause the on-chain transaction to be faulty. Yeah. And then with these, there are more details with that. And with these, there should be some best practice for blockchain security. And I classify them into the following. And I'm going to, there are about 13 or 14 of them that I'm going to mention here. The first one is that there should be a security risk mitigation plan, right? With this plan, the project team need to think about what if something goes wrong, right? For example, in this CryptoKitty case, they actually have a couple of rules there. They have a rule of CEO, they have the rule of COO, and then they have a rule of CFO. And then they have a function called pause. And only CEO has the privilege to call the function of pause, which means that if something really, really serious goes wrong, they can pause the smart contract. And then second thing about mitigation plan is to look at the trade-off between decentralization and upgradability. We know that blockchain is immutable, right? But sometimes things can go wrong. And how do you manage these kind of things, right? So one way to do it is that you can have 2 layers of smart contract. The first layer is simple, very difficult to be broken, and then the second layer is something that's upgradable, and with the tough, like complex business logic. If something really goes wrong, you can upgrade the second smart contract without changing the first smart contract. In this case, you can replace a new smart contract with the old one, but the top one still remain the same. So the application itself still look the same, but the logic actually changes, the bug get fixed. And then also there could be the mitigation plan is also rely on the community. And sometimes this kind of happened because something serious happened. You have to let the community make a tough decision. And we have a case with this one with Ethereum blockchain. The fork of ETC and the ETH was due to a DAO hack. And at that time, ETC decided to still do nothing, and so that the DAO hack remain with the chain. And the ETH community decide to change the state of Ethereum blockchain and to kind of mitigate that defect and then move on. And to some extent, the Ethereum main chain kind of changed the state of Ethereum blockchain, but that's the one that the people adopt now. So things does happen, and sometimes fixing an issue can cause a fork of an original blockchain into two chains. And the second one is to check both main source code and libraries. A lot of times, source code have import function to import a lot of libraries from third parties, and sometimes we only read our source code and modify our source code without looking at the libraries. That's not good. The developers need to look at the security of libraries as well, and then the library codes should sometimes have different versions, and they need to be looked at because these libraries can be an earlier version which have some security issues as well. Yeah, and then also need to make sure that smart contracts are open source and leverage the community to harden the security. Because smart contracts are decentralized, right? There's not a single big IT team to bring trust and security to the platform. So many times, project team need to make it open source so that everybody can look at the security aspect of the smart contract and then test out the smart contract and review it and harden the smart contract. And then another thing is to have the smart contract audited, and this everybody knows that sometimes, although auditing is quite expensive, and they also depend on the services. And for auditing, because they're professional teams who can look at the design of the tokens and also look at the business logic to make sure they are consistent. And this brings big value to the smart contract as well, and not just coding itself. And also the auditing team can also do a code security scan and also do some code manual inspection. And one of the most important thing for auditing is that they can also do the security penetration test. And this kind of expertise normally is not in the project team itself. So it's good, it's highly recommended to have the smart contract audited. And also make a smart contract logic readable. Solidity code as a major programming language for smart contract is different from other programming language. Like Java or C or C++, you can see that documentation of the business logic, the algorithm are separated from the source itself. In Solidity code, the documentation and the implementation itself are all in the Solidity code, so that both technical people and business people can read it and make sense out of it. So we need to make smart contract logic readable so that we can see that the implementation actually matches the business logic. And sometimes in smart contract, in good smart contract, there are more comments than the code itself, and that is good to some extent, so that everybody can read that smart contract and understand it. And also modularize smart contract. Solidity as a smart contract programming language is object-oriented, it's OOP. You can have a hierarchy, you can have inheritance, and you have also polymorphic mechanism. So the classes can be designed as modularized constructs. And then you can normally, it's recommended that you mimic the real world scenario and build a smart contract as the component of the corresponding business logic. And also you can also visualize the smart contract with some diagrams. Yeah. Another one is to use well-tested libraries. We mentioned that earlier, that smart contract main code can import source codes, other Solidity code, other libraries from third parties. And it's very important to use only well-tested libraries. Do not just grab some library from a random place and use it. Yeah, and also use a good random number generator. There are something that look random in blockchain, but they are actually not. So it's very important that with high value application, do not use blockchain hash or the blockchain time as a randomness function, because blockchain hash may look non-random and the time may look non-random, but because the miners can actually manipulate the block and hence the block hash as well. And then also they can delay the time of submitting the block, and sometimes these can be manipulated. So if you have a high value application that rely on random number generator, use an external one, do not use the one that's generated by hash or time in the blockchain. And then another thing that's very unique with blockchain is the gas consumption and in the security context. Public blockchains has gas fees for all transactions, and then sometimes the denial service or the damaging of the smart contract can be done by sending transactions with some gas high value gas consumption, right? And so when you write the smart contract, you need to avoid a big while loop and also optimize the gas consumption, and then also look at how users are going to pay the gas fee for the transactions. Yeah, wisely we use the blockchain. Sometimes for people who are not familiar with blockchain, they intend to think that blockchain can replace internet applications. That's normally not the case, because blockchain is expensive, right? All the gas fees, transaction fees, and all these decentralization trusts are very expensive. So only use blockchain for systems that require a decentralization trust, multi-party consensus, immutability, and transparency. If you have a big application like video management, you probably need to put the video storage as a separate application, and then make the video subscription and paying loads as a blockchain function. So just wisely use a blockchain for things that are needed. And then stay on top of security breaches and patches. The blockchain is good. The information are open. Sometimes one hack happen, it may impact other applications. So stay on top of those news, and then apply the patches or VCM's fix into your application. Yeah, and then another thing that's extremely important is that we need to deploy the smart contract with hardware wallets. Sometimes when we deploy the smart contract, people forget that the private keys can be open to hackers, and they just use the online wallet or hard wallet to deploy the smart contract. That is not good. That's not good security practice. You actually need to use a hardware wallet or use a offline wallet to sign the transaction for the deployment and send it online. So you have two steps. One is to sign it offline and send it online, or use a hardware wallet directly, so that the private key will never leak the system they are in. And this happened several times already. There is private key stolen during the deployment time, and then the smart contract is managed by the hacker, not by the project team. Yeah, these are the best practice for the blockchain security itself. And I'm going to go to cross-chain security consideration. Yeah, cross-chain technology is a technology where you connect the different blockchains with bridges. So in this illustration, we have three blockchains: blockchain A, blockchain B, and blockchain C. And then we have three entities that provide their services: one is Enterprise 1, Enterprise 2, and Enterprise 3. And then here we use a relayer node to connect the bridges. Like Enterprise 1 can use a relayer node to connect blockchain A, B, C, and Enterprise 2 connect B and C, and Enterprise 3 connect A and B. And so this is the topology for cross-chain bridges. And this is a architecture that's produced by EEA. Basically, EEA classify the blockchain, cross-chain layer into several ones. The bottom one is the network layer, and above that is the core blockchain layer with storage, execution, and consensus. And then we have enterprise layer with privacy, performance, and permissioning. And then we have tooling layer, management, the interaction libraries and RPC, etc. And then we have the application layer where you have decentralized applications, contract and standards, smart contract tool, etc. And I use this diagram because we are going to classify the security into these corresponding layers. And by the way, this is a EA architecture. You can find it in our EA website. Oh, I get some questions. Oh, I'm looking at the questions. Yeah. Yeah, these are questions. I answer a couple of them here. Will this presentation be shared? Yes, they will be shared. And then East Trust, the working group, is close to publishing a standard minimum for smart contract audits. Oh, that's great. Yeah. Yeah. And the first one, I'll come back to it later. Yeah, thank you for the questions. Yeah, if you have any other questions, yeah, please just send it through the Q&A or through chat. Yeah, so these are EA architecture, and then I'm going to go through. Yeah, the security side of it. So when you have a cross-chain platform, you need to look at security in different aspects. First one, you need to look at source chain security. All the security, all the hack in source chain will impact your cross-chain. Because, for example, if you have an asset locked in the source chain and then transferred to the target chain, if the source chain get hacked, then the source chain asset lost value, but the target chain asset can still be traded in the target chain. So it impact the whole token system. And the target chain security, same thing. If the chain hacked and the target chain, then it impact the bridge as well. And it's very complex because with Ethereum, we know that the chain security is almost guaranteed after so many years of operation. But sometimes you have a new chain that's operated by a couple of people, by a small team, then you need to look at the security of the source chain and target chain more carefully. And then there's a bridge security. And then we also look at different layer of securities for cross-chain. And also we want to look at the staking and slashing. And this is important for open bridge, because these bridges operators are not trusted. They are permissionless. Anybody can be a bridge node. So they need to stake asset to run as a bridge operator. And also look at the bridge randomness as well. Yeah, this is just a more detail of possible security hacks. The source chain and target chain smart contract, those can be hacked. That I mentioned those already. And then the cross-chain bridge, there could be collusion, finality, rollback. Collusion is a case where the bridge node operators actually get together to provide the service, but actually they are stealing the fund when they are doing the transfer of assets. And finality is a case where you have a transaction in the source chain and you saw it's final, and then you mint the asset on the target chain, but then the source chain is not final. It actually get rolled back, get reverted, and then the asset is minted on the target chain already, and that caused the security issue on the target chain. And then rollback, same thing. You have a chain that's going on well in the source chain, but suddenly it get rolled back, but the target chain doesn't get rolled back, and this causes issues. Yeah, and I think Ethereum actually, Vitalik actually published an article talking about his concern about cross-chain security with cross-chain bridges. Yeah, and then those are valid point, and he's talking about multi-chain as well. But these are solvable, and they need to be solved. Yeah, and there are different ways to help improve the security. It could be trusted bridge operators, MPC, multi-party computing, and also the rotation of bridge node and the slashing mechanism. Yeah, so now look at the different layers of blockchain that we mentioned. The first one is the blockchain layer, right? When you want to connect to blockchain, one of the first important thing is to be able to discover and uniquely identify blockchains and securely identify blockchains. You cannot try to connect to a malicious blockchain. And in this case, one of the things that is important is to be able to identify the blockchain. And today we know that chain IDs, EIP155 has been used to identify blockchains. And in this spec, basically Ethereum is assigned as number 1, and then the other testnet are assigned number 3, number 5. Yeah, but these are not good enough because when you have an integer to represent the blockchain, the chance for collision is big, and also it's not scalable. You cannot use those blockchain ID for the enterprise blockchain or other heterogeneous blockchains. And actually, EEA, Ethereum Crosschain Interoperability Workgroup actually proposed EIP 3220. In this specification, we use a 32-byte hex number to represent a chain ID, and we also have 16 bytes to affiliate with the blockchain hash, the genesis block hash or the fork block hash. So using this spec, we can actually uniquely identify not just the blockchain but also the fork of blockchains. So this is we submitted this already. And then also need to pay attention to the chain protocols. There are some blockchain may have its own protocol. I put EIP, XIP here. Like Ethereum has Ethereum IP, EIP, and then Cardano have a CIP. But other blockchain may have their improvement protocol. Sometimes these protocols may not be valid because there's a small team, a small community working on these protocols. Need to make sure that the source chain and attack chain at the blockchain layer, network layer are kind of safe, secure. Yeah, and there's the second layer is the consensus layer. There are miners running mining nodes and proposed blocks. Need to look at who runs as miners for the native chain, the source chain, target chain. And then what consensus algorithm is used for the blockchain? Is it a BFT? Is it a POW? Is it POS? If it's POS, who has that S? Who has the stake to govern the randomness and the fairness of the block proposal proposing? Yeah, and also look at the finality. Is it a single block finality just like BFT, or is there some 12 block, 30, like 30 or 50 blocks finality? And also look at the risk of blockchain rollback and forks. Yeah. This is a consensus layer. And then the relayer. Relayer is a layer to carry the asset, to transfer the asset and message and event and commands from a source chain to the target chain. And this is an off-chain operation. So it's more difficult to secure it because they are not on-chain. All the blockchain features like immutability and the transparency are not governed here with the relayer. So it's very important to look at the relayers to see whether they are permissioned or permissionless. If they are permissioned, then it need to be governed by trusted administrators. And then if it is permissionless, then it should be governed by asset staking and randomness and multi-party computing. Yeah, and then the going up is the smart contract layer. So there are several things you need to consider. One is that when you deploy the smart contract, the private key need to be guarded by HSM, the hardware security module, or key management system, KMS, or hardware wallet or offline wallet, or some secure wallet, vault technology. It's very, very important to secure that private key for the smart contract. You can also share ownership of a smart contract with multi-signature wallet, and this some bridges actually uses that, and you can see that some bridges are hacked because of the multi-signature wallet was not safely guarded. Okay, like some project use like 2 out of 4 to secure the smart contract, but 2 of them get hacked. So it need to be make sure that these are secure. And also another thing to consider is to denounce the ownership of the smart contract. And then this one has the drawback of upgradability. Once you denounce it, nobody can hack it with the private key, which is good. But you also have the drawback of updatability. Yeah, Oracle layer is another one. Oracle is to bring information from legacy system to IT system to the chain. It's challenging because Oracle is need to be trusted, and sometimes to trust Oracle is not easy because Oracle, for example, the pricing information provided by Oracle is very difficult to to ensure that the pricing they provide is accurate, and it's accurate all the time. So sometimes they have to average it. So these are the challenges with Oracle as well. Yeah, I think more work need to be done in this Oracle area to have a standard for that. Yeah, and then the web service layer. This is another thing. Some people think that blockchain are decentralized, and therefore everything is decentralized. But when you actually build a tab, there is actually a web service layer that provide a web interface, browser application for the users, right? And this browser application, this website actually aggregate user actions and transform them into a blockchain transactions, raw data, and then send it out to Web3 client. And sometimes people can hack this one. For example, you have an online wallet platform that sends transaction for the users, and those online wallet need to be safeguarded. So all the security consideration for web should be followed. And basically, I think it's strongly not recommended for users to use online wallet. They need to link their wallet to the hardware wallet so that there's no hack on the browser to steal the fund. Yeah, even with MetaMask, you can still link it to a hardware wallet. Yeah, and then separate the private key storage and transaction signing from any web service, which means that the web service cannot get a hold of the private key and sign it and send it out. The signing should be separated from the online service itself. Yeah, administrator account is another thing. The administrator account that manage the blockchain, manage the whitelist, that need to be safeguarded. And then we're using MPC. MPC is a technology where the private key is sharded into pieces, and different account owner owns a part of it. And then the whole private key is never generated or stored. Everybody has a piece of it, but nobody has the hold of it, the whole private key. And each MPC node can sign transaction individually, and then they send send the transaction they signed, and then aggregate the transaction, and then the whole aggregated transaction is sent to the smart contract, and that thing is considered as a groove signed. So it has security because the private key never get revealed, or it will never get hacked. And then staking and slashing is a safety measure that where the bridge operators need to put some stake through smart contract to ensure that they will not do something wrong. They to prevent collusion, right? And this is similar to POS, proof of stake. It's the proof of stake for bridges. Yeah, and then in activity slashing, there could be two kinds of slashing, just like ECM2. If the bridge node is not working, it's not online, there's an inactivity slashing. But if the bridge node actually construct an embedded transaction, there's a fraudulent slashing as well. So these are the security measures to ensure that the cross-chain bridges are secure and trusted and reliable. Yeah, another one more thing I want to discuss is that what if things really go wrong with bridges, and this is the emergency handling case. I come up with 5 here. If really a bridge goes wrong, right, there should be a mechanism to pause the bridge, and this could be a case where all the bridge nodes stop working, and then the majority of the bridge nodes stop working, or there can be some mechanism for that, and this need to be discussed by the bridge operators. And then the snapshot of blockchain state should be taken. There should be a capture of the source chain snapshot and the target chain snapshot. And this is for compensating the losses if needed, and also could cause the problem as well. And this is different from the bridge itself. Another thing to consider is the capping the bridge. We have seen so many funds get stolen in the bridge. And sometimes the bridge node, they only have a very limited security implementation, but they carry so much asset. And technically, you can cap the bridge so that you limit the amount of asset that can be transferred across the bridge. And then there should be a effective upgrade path where in case something wrong, you can upgrade the smart contract in a safe, secure measure. And then finally, there's a staking and slashing mechanism for bridges. Yeah, and I think I have these, and this is the end of my presentation. I welcome questions, and also I see some questions coming up in the Q&A session. Oh yeah, I have the one from Manuel Macau. He's asking, is there a certification or standardization or something similar that application can apply for that ensure they follow these security best practice? That's a great question, because this, when in EA discussions, we always think that EA can play a good role in this. EA can have a guideline, have a practice, best practice, and even have some training program. And then the project team can get certifications from EA or IEEE. So at this time, I do not see there is such a program in cryptocurrency space, but I think this is something that's good to have. And this is something that's either Hyperledger or EA should play a role over here. Yeah, but welcome ideas on this one. We talked about this several times in several occasions. If somebody wants to form a certification and standardization group for security, that'd be great. Yeah. Oh, yeah. The next one is what is the state of automatic smart contract audits that can self-execute upon code upgrades to mitigate breach hacks, such as what happened with Nomad. Yeah, Nomad itself has three issues. First one is that the confirm add initialization issue, right? And that not even a normal user can cause damage to the bridge. Okay, so that is as I see, that is a functional issue. And second one is that they have an updater. The updater can also kind of a path to kind of manipulate the confirmation of that Merkle tree hash, and they have some privilege on that. And this updaters is assigned by the owner of the smart contract, and the owner of the smart contract also have a modified confirmation method. So it's very complex. So to answer this question, the answer is no, because you have three places that can go wrong. One is the initialization, the updater assignment, and then also the owner has the modified confirmation method layer. So it's so complex. There's no way you can write an automated program to do this. So I would say, yeah, it's not possible. It's just too complex. The smart contract and the breach operations for that. But I think some guidelines, okay, some open review, some of the auditing will be very, very helpful. And then also for the automatic security scan of smart contract, there are some security scanning tools for Ethereum, but those are based on static coding errors, right? For dynamic ones, for the one that shows in the operation of the smart contract after it's deployed, there's no way for the security scanning tool to detect those. So it's very limited, and that's why in the slides I mentioned that you can have security scan. That's just the first step, and then you need to have the manual inspection of the smart contract and combined with business logic, and then you also need to have a penetration test on that as well. I view this more as an enterprise effort. It's not something that you can provide a tool and make it do the work thoroughly. Does this presentation actually include a top 10 list of some sort? Top 10 was given by Ken, and I tried to make it top 10, like a top 10 centralized exchange hacks, and also top 10 which hacks. And then for the best practice, it go beyond top 10. That's why in the best practice, I have a almost top 13, 14. If 10 is a magical number, we can try to have something like that. But at this time, I just use that as a topic. We have a couple of tables with top 10, but the others we have top 5, top 6, sometimes top 13 and 14. Oh, this is an excellent presentation. Thank you. Thank you, Michael. Yeah, has EA, then one more Gilbert, has EA thought about how you may map security to a zero trust framework? Not that I know. Yeah. Yeah, I feel that there need to be more work done on security, but it's very, very challenging. That's when we are writing this Crosschain security guideline, it took us a lot of effort to look at different aspects of it, but we can only write a guideline. We cannot even write a spec for it. So if we want to tackle this task, it'll be challenging. Need to involve a lot of experts in this field. Yeah, and then the Ben sent a link from Ethereum on this one for certification levels on code. Yeah, I think we can yeah, yeah, people who are interested can do this one as well. Yeah, any other questions? Oh, there's a chat question as well. Okay, this is from YouTube. So if I wanted to be a blockchain security expert, do I need to learn blockchain core dev? I'm a blockchain app dev. Yeah, I think that's a great question. Actually, I'm teaching at the University of Texas, and the security is a very complex one. And some people are business students, some people are very, very engineering students. I think there are different layers, right? The core layer is more complex, and security can be at business layer or could be business logic layer, could be in like token economy, right? Those are at the business layer. And there's a coding layer, like for example, smart contract layer, and those anybody can do that. Okay, when I teach Solidity programming, I can say that you can anybody. I don't need any prerequisite for that. You can be a good Solidity programmer. And then for security, you just need to look at the best practice and also look at all the things that can go wrong from business side and the coding side, and that may require some work, a little bit more challenging than the program itself, but it's still doable. You don't need to know like Go language and other things. Solidity is very straightforward. You can still learn a lot about security just by looking at the Solidity program language itself. And I think the answer for this is yes. You don't need you can be a security expert without learning the core dev stuff for the blockchain. Yeah. Any other question? Let me look at Q&A as well. I think there's one. See if there's one more. Oh, I think that's it. Yeah. Yeah, actually, I have the first question I skipped here during the presentation. So the question is about there are traditional hacks that's leading private keys more and more, and how and why are wallet provider and centralized exchanges storing users' private keys on a server somewhere? Yeah, they should not, but sometimes just for large scale of users, and they probably think their system are very secure. but there's really no system that's really 100% secure. There need to be some, HSM or offline wallet or hardware wallet or secure vault will be good for these. And there are other things beyond the technology itself, which I do not cover here. The human factor, which I do not cover here, and those could provide answers to some of these questions as well. Yeah. Okay. So, thank you. Thank you all. Brittany, I pass back to you.